Hi everybody. So today we get to learn about vectors on the coordinate plane that we're used to seeing, so that we call that R2. But we also get to learn about vectors in 3 dimensions. So for the first time, we get to consider an X, Y, and Z plane. So imagine, well, when we get to that, I'll talk about it. So we call our normal coordinate XY plane, we call that R2. And the 3-dimensional plane we call R3, and I'll explain in a second why we do that. So it is useful to represent vectors in the XY plane, R2. R2 means that each of the X and Y coordinates is a real number. So that R is really meant to represent real numbers. So R2 is defined by, I'm just going to set up here. R2 is defined by the set of all X and Y coordinates such that X and Y are real numbers. Okay, so it's the set of all XY coordinates and a combination of 2 real numbers. So here we have an X and a Y axes, and we can draw a vector OP. So a vector OP always has its tail at the origin. So its tail is here at the origin. So that's the O, which stands for origin. And then we can just draw it out to any point, which we will call P. So this is a vector OP. And it can be represented by the coordinates A, B. Okay, so where A is the X value, however high that is. So here is A. And then here is B. This length is B. So OP can be represented in coordinate form as just AB, whatever the coordinates of point P are. Okay, so since each point is a unique real number, so the vector OP has a unique representation on the XY plane. So that means if you have a vector OP, it is a unique vector. Or if you have a point AB, it can be represented as OP with O at the origin, and again, the head terminating at the point P. A point with its tail at the origin and its head at a point is known as a position vector. This is an extremely important definition. So a position vector is a vector where its tail is at the origin, okay? So if you had, this is kind of a separate aside, you don't have to write this down. If you had a vector that looked like this, just chilling out there in the middle of space, its position vector would be at the exact same angle, the exact same length, but just translated so that its tail is now at the origin. So this could be called vector V, and this would be the position vector of V. So that comes into play later. So here we go, 3D, exciting stuff. Okay, so now we have 3 planes. So imagine we have X, Y, and then a Z plane. Okay, so now we can look in 3 dimensions. Now, what's a little bit strange is that we would think that this here would be X and this would be Y, because that's what you're used to, and then Z would be coming out. Sorry, it's not that easy. When we get into this system, we actually call this the X plane, this the Y plane, and then this is the Z plane going up and down. Okay, so the designation R3 is useful for 3 dimensions since all coordinates of points A, B, C, and then the associated vector is OP equals A, B, C are real numbers. Here, the origin is 0, 0, 0. So all coordinates in R3 have 3 numbers, not just 2, to represent their X, Y, and Z locations. Okay, so in R3, we have the X, the Y, and the Z axes. Each pair of axes is perpendicular and is a copy of the real number line. So this, going this way, that's positive X, and going this way, that's negative x. Here's positive y and negative y, positive z and negative z. Okay? So there are 3 planes. There's the xy plane, which in this case is here. So this could be represented as the xy plane, okay? And then the xz plane is this guy here, okay? So kind of up and down. And then there is the let's start this again. The xy plane is here. So that's between x and y, this bottom of the box, okay? That you can see. The xz plane is the side of the box, so anything there. And then the yz plane is the front of the box. Okay, so if you want to think about this, the xy plane, you can get some color coding. So the xy plane, this is part of the xy plane. So I'll just color code it there. And then here we have the xz plane is here. This is very official what I'm doing. That's the xz plane. And then you can see the yz plane would be this one here. Okay, and then it would extend infinitely from there, both ways, but in that box you can see it that way. Okay, and so when we come up with our coordinates, we're always going to move x first, then y, and then z to get our final point. So up the x-axis, and then left or right on the y-axis, and then up or down on the z-axis. So we're going to go through and do that. So the best way to kind of visualize this is to create a box, which I'm going to show you guys how to do. And it really helps you to use a ruler to actually measure this, believe me. Okay. And you'll get your accurate results this way. So I'm hoping that this translates on the video, but I don't have a ruler to show you. So I would recommend getting one out, though I will talk you through it. If it's really confusing, again, I'll go over it with you one-on-one, or I'll show you on the board in class, but hopefully this gives you at least an idea. So instead of an ordered pair, we call this an ordered triple, and each point creates a vertex of a right rectangular prism. Okay, so step 1, I'm going to try to color code this as much as possible. So, label these as X, Y, and Z. It's going to be really important at the beginning to remind yourself where they are. So the first thing you do is move along the x-axis. So for the purposes of this demonstration, I'm just going to assume that all of these coordinates are positive. So I go do until I get to this point. So this point, I can call it A, capital A, and it would be the point A, 0, 0. So if I have a triple ABC, I've applied the A. So that's the first step. You just go right along the axis there. Okay. So that's step 1. Step 2 is now I'm going to move perpendicular to the XZ plane in the Y direction to ABO. So I think about this as you should be moving exactly parallel to the Y axis so that you are perpendicular to the XZ plane. So you might want to change this actually to say parallel to the y-axis. So you want to make sure that it's exactly, you're going straight out. You don't want to like go weird or wonky places. So I go B units out as far as I need to here. So from here, I travel B units until I get to that. So now this is the point A, well, we'll call it capital B, but it's the point I've applied A, I've applied B, but I haven't gone up or down, so Z is still 0. Okay. So now, from there, I'm going to apply my Z. In this case, again, like I said, I'm going to go up. So I'm moving perpendicular to the XY axis or plane, or parallel to the Z plane. So I should be going perfectly up or down until I get to my C. So now I've applied my A, my B, and my C. So this is my final point, which I will call P. So then my vector, my final vector, starts at the origin. Oh boy, I wish I had a ruler. And goes right out to P. So you have to kind of imagine that coming out from the origin 3D out into space and hitting that point P. Okay, so now what helps us visualize this is if you create a coordinate box. So what this box is it creates a base on here. So the base that I'm going to create on the bottom, so now from B, I want to move parallel to the x-axis. Okay, so you want to, again, this is where a ruler helps because you can line it up and then move it over. There you go. So then there, that is the point where all I've applied is the B. So I didn't go up or down on the X yet. I went over to my B, but then I haven't gone up or down yet, and so that's C. Okay, and then, so that creates the bottom. Okay, and then from here, I can go up as far as that P is up, but from this position, okay? So in this case, I have gone up to my A, but then I didn't go left or right, so I have 0 on the y-axis, but then I did apply my C. So then I can connect these here. That's the front of my box. And back here, I can do the same thing. So this one from this point should be the exact same height as from here to here. I'm just starting from here. So in this point, I haven't gone up or down X, but I've gone over B and up C. So this is 0, B, C, and so I can connect it there. And that's the side of my box. So I have the bottom here, and then one side, the front. And then from the origin, I can go up Z as far as I was supposed to. So that is just 0, 0, C, because I didn't go left or right. And then you can finish your box. Didn't do too bad for a trackpad. Okay, so this is the right rectangular prism, which we call the coordinate box, okay? And the vector OP cuts directly from the origin through the box up to the opposite side. So these coordinate boxes help you get oriented as you're getting used to R3. So let's actually create one with numbers. Hopefully this becomes more clear. So I would get a ruler and actually think of a scale. I think maybe 0.5 centimeter per 1 would be a good scale for you. So 1 unit equals 0.5 centimeters. I think that works on this. So you can put a hash for every like 2 centimeters. So there's 2, there's 4, and there's 6. Hopefully you can actually mark it. Okay, so we're gonna create we're gonna go ahead and actually do this. So the first thing we do is go to our X value of 6. Okay, so our first point that we're going to write is 6, 0, 0. And actually, I'm gonna do this in the same color scheme as above. What did I start with? Okay, light blue, green, and then red. Okay, so I'll start with light blue. So there, I should have written that in light blue. So I'm going to go 2, 4, 6. So here is my point. 6, 0, 0. Now from there, I'm going to go 2 units out this way. So this is where it helps to take a ruler and measure 2 units, which in this case is 1 centimeter. So I'm just going to eyeball it. It should be about there. So now that's the point 6, 2, 0. And from there, I want to go, oh shoot. Okay, sorry, I should have written. So my second step is doing the point 6, 2, 0. And now I want to get my red and go 6, 2, 4. So again, you want to measure, in this case, 2 centimeters or 4 units up. So it should be just past the axis. So there you have the point. Oh, it's hard to write in here. 624. Okay, I'm going to label that later when I see where my box is. But that's 624. Okay, so now there's and so I can draw my vector OP. So imagine that's coming, so the box is sitting on top of this positive XY plane. So X, Y, Z, and then going up. That's where the box is going to be. So to finish the box, I like putting the intercepts first. So 6, 0, 0 is an intercept. We got that. And then 0, 2, 0. And then 0, 0, 4. Those are going to be the intercepts. Okay, so I can draw my box starting there. And then I can kind of connect my points. Like I can connect this, and I can connect this. That's the bottom. Notice how these two lines are parallel, and these two lines are parallel. And then I can connect this to here. So I need another point here, and I need another point here. So this point here will be going straight up. So that is 0, 2, 4. Because I haven't gone up or down this axis, I've just gone over and up. So that should be parallel to this axis. And then this is parallel to this. Then we connect these. So these two should be parallel. So now we just need a point here. So from here, we go up Z. So that is 6, 0, 4. Go up to it and over, and then we just connect our box. So to me, that's the best way to make the box, is to do the intercepts and then try to kind of fill in the blanks of what you haven't drawn yet. Okay, so now that I know where my colors, I just didn't know where the box was going to be exactly. So I had to draw them like this. So that is the point 624. I just didn't want my box to interfere with it. So there you go. Okay, there is example 1. All right, so if you feel like trying example 2, I would encourage you to do that. And you know what? I'm gonna leave that and then take it up. Actually, you try it and then I'll show you a picture of what mine looks like if you can see it. Let me see if I can get my preview screen on here. I hope you're trying it right now. Are you? Okay. This is what it should look like. Ooh, can you see? It's on the side now. It's on the side. Where my fingers. Oh, there. So maybe, hopefully, you can see that. You can pause it and look at it. Take it up tomorrow. Super fun. Okay. Oh man, high technology going on at UMEI. All right, question 3. So I intentionally didn't draw the XYZ plane here because you guys also have to get used to actually constructing your plane. So take out a ruler and let's actually learn how to draw the XYZ plane as well as we can. So I always start with, use oh my word. Use a ruler, unlike me, which is really tough on the trackpad here, but I will do my best. Okay, so do your up and down. I'm just gonna do it right in the middle of the page. Oh my goodness, why is it the worst I've ever done? Okay, and then go this way. Okay, and then you wanna put your X plane, but it should be cutting this in half, so like at a 45-degree angle. So I just either get out a protractor or try my best to cut that in half. That's not too bad, but rulers help. Oh my gosh, how is that not even straight at all? There, like, sometimes I wonder. It's just ridiculous. Like, okay, there we go, Mrs. Wings. Okay. All right, so let's draw Q. So I'm gonna go a little bit quicker with this guy. I'm not gonna color code him, I'm just gonna give her. So we go 2 up this way. and then we go -3, so in this direction. So there's -3. And then we go down 5. Okay, so here's, in this case, the top of the box. So our vector is going down and across. So we would have a front of the box here, side of the box here. Okay. There we go. So this is the point Q, 2, -3, -5. So I went up 2 and then left 3 and down 5 to get to Q. So there's my vector. Okay, so that was part A. Now, kind of unrelated, write an equation for the XY plane. So the XY plane has the equation Z equals 0. So think about why this is true. And the XY plane is basically the set of all points X, Y, 0, where X and Y are real numbers. So the only way to define that is by letting Z equal 0, because X and Y can be anything. Just like if we were to define the Y-axis, we would say X equals 0. So when we would define the XY plane, we say Z equals 0. So now first we need to know what P. So this is point P here, okay? This is M. Here's our Q, and then T is back here. So they want us to write an equation for this plane here. So notice that this point P has gone over, this is the point 0, -3, 0. This M is the point, so I've gone my 2 and my -3, but then I haven't gone up or down. And then my point T here is, so I've gone over and down, so 0, -3, -5. So what is the same about all 3 of these points? Y is the only constant, okay? In this plane, it is perpendicular to the y-axis. So it cuts through the y-axis at the same point. So the only thing that is constant in this plane is y. So the equation for that plane is actually just y equals -3, because that is the only thing that is constant. Everything else is changing and variable. So another way you could describe that plane is the set of all values a, -3, C, where A and C are in the set of all real numbers. Okay, but this is the equation for it. So write a mathematical description of the set of points. Oh, I just did that. Okay, that's for the whole plane. But if you're talking about just the rectangle PMQT, you would have to not say that they're all real numbers. You would have to say that you would have A, -3, C, but within that rectangle, A is between 0 and +2, and then any real number in between. And C is in between -5, no comma there, and 0, and it could be any real number. So without these restrictions, so this up here represents the whole plane if it continued in all directions. And this description here represents just that rectangle because it gives boundaries. Okay, thanks for watching, guys. Hope you learned lots.